Example number 1. Solve for the variable t. When solving this formula for t, we consider all the other variables as constants. For instance, if we had 6 equals 3t, then in order to solve for t, we would divide both sides by 3, and we would end up with t equals 2. I do the same thing with the formula. To solve for t, I'm going to divide both sides by r. The r's will reduce to 1. And I have the equation or the formula solved for t. T equals d over 9. Solve for t. Example number 2. Solve for r. Just like the last example, I'm going to isolate the variable r by dividing both sides by 2 pi. The 2 pi over 2 pi reduces to 1. And I have it now solved for r. R is c over 2 pi. Example number 3. Solve for x. Now, just like if I had the equation 2x plus 3 equals, let's say, 7, my first step would be to subtract 3 from both sides. 2x equals 4, and then I would divide both sides by 2 and get x equals 2. I'm going to do the same thing with my formula. I'm going to first subtract b from both sides. Now, on the left side, we have a times x equals, on the right side, c minus b. Since I don't know what c and b are equal to, I have to just leave it as the difference c minus b. Now I'm going to divide both sides by a. The whole side divided by a. These a's will reduce to 1, and I have x equals c minus b over a. And I have it now solved for x. An equivalent way to write that answer would be to put the denominator under each the c and the b. We could write that as c over a minus b over a. That is also a correct way to write the answer. Example number 4. Solve for y. So my first step is going to be to subtract 2x from both sides. On the left now I have 3y. On the right side I have 6 minus 2x, or we could put the negative 2x in the front, it doesn't matter. I'll write it as negative 2x plus 6. Now I'm going to divide both sides by 3. The 3's reduce to 1, and I am left with y equals negative 2x plus 6, all divided by 3. We can leave our answer like that. Or, if I do put the 3 under each part, I could write this as negative 2x over 3 plus 6 over 3. This is equivalent to this. And then I could even reduce the 6 over 3. Y equals negative 2/3 x plus 2. So both of those are correct ways to write the equation. Example number 5. Solve for w. My first step, I'm going to subtract 2L from both sides. That gives me P minus 2L on the left. This is gone. This is 0. And so this equals 2W. Now, one more step in solving for W. I'm going to divide both sides by 2. Divide by 2. Divide by 2. These W's cancel, or these 2's cancel away, and I'm left with, let's write this backwards here. This is W equals P minus 2L over 2. And so that is one correct way to write the solution. Just like in the last example, I could also write it this way. If I split that fraction into two fractions, putting the 2 under each part, like that, I can reduce these 2's, and W also equals P over 2 minus L. Example number 6. Solve for H. Now, I have a fraction that I would like to get rid of first, and so what I'm going to do is multiply both sides by the denominator 2, times 2 and times 2. On the left side we have 2a. On the right side, the 2's reduce to 1, and I have b times h. The next step in solving for h is to divide both sides by b. Those b's cancel away or reduce, and I now have it solved for h. H will equal 2a over b. Example number 7. I have a fraction that I want to get rid of first, just like in the previous example. And so I'm going to now multiply both sides by 3. That eliminates the fraction. I now have 3z equals y minus 2. Now to solve for y, I have to get rid of the negative 2. Or since the 2 is subtracted from the y, to get rid of it, I'm going to add 2 to both sides. So that's a 0. And I end up with y equals 3z plus 2. And we have our equation solved for y. Example number 8. Solve for f. This is a formula from, I guess, a science class. It converts Fahrenheit readings to Celsius, but we'd like to solve it for f, for Fahrenheit. Now, there's a couple ways to go about solving this for f. Here is one of them. I could get rid of the fraction entirely by multiplying both sides not by 9, but by 9/5. In other words, I'm multiplying both sides by the reciprocal of the fraction 5/9. The 9/5 times the 5/9 reduces to a 1, and so it's gone. I now have 9/5 c equals f minus 32. Now all I have to do to solve for f is add 32 to both sides. And my answer is f equals 9/5 c plus 32. Now an alternate way of solving this for f which I believe would take a little bit longer, but is also correct, is to first multiply both sides by the common denominator, just 9. That eliminates the 9s, but I'm still left with 9c equals 5 times f minus 32. Distribute the 5. 9c equals 5f minus 160. Remembering that we are solving for f, I would then have to add 160 to both sides. 9c plus 160 equals 5f. And then the last step would be to divide both sides by 5. And I would get f equals 9c plus 160 all divided by 5. And that is equivalent to our original answer there. If we split that into two fractions, putting the 5 under each part, it will reduce to 9/5 c plus 32. Example number 9. Solve for a. Now notice that in this problem, we have two a's in there. We have an a times a b and a 3a. And so what I'm going to have to do is the distributive property in reverse. In a later chapter, we just call this factoring. I'm going to factor the a out of both terms, and that leaves me with b plus c in the parentheses. This is the distributive property, since if I were to go and distribute the a back in, this would be a times b, which is right here, and then the a times 3 is the 3a, so they are equivalent. Now I have a times this quantity b plus 3. I treat the b plus 3 as one number. I divide both sides by the quantity b plus 3. The b plus 3's reduce to 1, and I'm left with a equals c over b plus 3. The formula is now solved for a. If you have your variable appearing more than once, most likely you will have to use this distributive property or factoring in order to solve for the variable. Example number 10. Solve for w. Now I notice that I do have a w here, and also I got a w times x there, and so those terms must be all moved to one side so that I can factor the w out and use my distributive property. First I'm going to first add the 7 to both sides. I'm going to move the 7 to the other side. That gives me 2w equals wx plus y plus 7. Now I'd like all the w's on one side, and so I'm going to now subtract the term wx from both sides, which gives me 2w minus wx equals y plus 7. Now I can use the distributive property or factoring the w out. 2 minus x would be left in the parentheses, and that equals y plus 7. Notice that if I distribute the w back in, I would have what I had originally up here, 2w minus wx. Now I can divide both sides by 2 minus x, the entire quantity, 2 minus x, and I end up with w equals y plus 7 over 2 minus x. And we have it solved for w. Now I could have gotten a different answer, which is also going to be correct, if I had moved the w's to the opposite side instead. So let's try this problem again, solving it in a different way. Let's say I had subtracted y from both sides first. 2w minus 7 minus y equals wx. Now I still need to move all the w's to one side of the equation, but now I'm going to move them all to the right side. So I'm going to subtract 2w from both sides. This gives me negative 7 minus y equals wx minus 2w. On the right side now, I have to factor that w out, or in other words, use the distributive property. That's w times x minus 2. Okay, distributive property. Now I can divide both sides by x minus 2, the entire quantity. And I end up with w equals negative 7 minus y over x minus 2. And this is also a correct answer. Next example. Solve for t. I believe this is example 11. Solve for t. I need to get rid of the fraction first, so I'm going to multiply both sides by the denominator t times t, and this side times t. On the left side we have t times c, or c times t, equals, the t's there reduce, cancel, negative 3t plus 5. Now, it would be incorrect to divide both sides by c here because I do have t's on both sides of the equation. I must move them all to one side. So I'm going to move this term, 3t, over to the left. I now have c times t plus 3t equals 5. Since all the t's are on one side, this will allow me to factor the t out, or in other words, use the distributive property. I can then now divide both sides by the quantity c plus 3. And I have the answer t equals 5 over c plus 3. Solve for t. Example number 12. Okay, this is an application of a formula. This is the formula d equals r times t. D is distance, which is equal to your rate or your speed multiplied to the time. So I'm going to plug our information into this formula and find the average speed or the rate. You take 3/4 hours to drive 15 miles to work. What is your average speed? The distance is 15. The R is what we're looking for, and the time is 3/4 of an hour, so 3/4. Now I want to solve the formula or the equation for R. And one way to do this in one step is to multiply both sides of the equation by the reciprocal of 3/4, which is 4/3. Three-fourths times 4/3 reduces to 1. So I have R on the right side. On the left side, the 3 will go into the 15 5 times. 4 times 5 is 20. So our rate is 20 miles per hour, average speed. Example 13 has to do with percents. To get the percent, you take a partial amount and divide by the total amount. This gives you the percent as a decimal. For example, out of 50 students, 32 are female. What percentage of the class is female? So we take the partial amount, 32, divided by the total amount, partial amount, divided by the total, and we divide and get 0.64. As a decimal, the percentage is 0.64, or moving the decimal place over 2 places, this is 64%. 64% of the class is female. Example number 14. "10 liters of acid is mixed with 40 liters of water. What percentage of the resulting mixture is acid?" So we have the amount of acid, which is 10 liters, that's the partial amount, divided by the total, which is not 40 because you're adding 10 liters with 40 liters of water, so the total is actually 10 plus 40. 10 over 50. 10 divided by 50 is 20, or 0.20 that is. And as a percentage, that would be 20%. 20% is acid. Example number 15. If a balance of $3,550 earns 8% interest in 1 year, how much interest is earned? Okay, if we let x equal the interest, this is the partial amount. And so we know that the percent, 0.08 as a decimal, is equal to the partial amount over the total amount. And so 0.08 is equal to x over the total amount of money was $3,550. In order to solve that for x, the amount of interest earned, we multiply both sides by 3,550. And we end up with x equals $284. And that's interest. In interest. Oops. A much simpler way of doing this problem would simply be to say you want 8% of 3,550. Usually the of here means multiplication, multiply. And so I want 0.08 times 3,550, which of course gives me the same answer, 284. Okay, and so that is our lesson on solving formulas.